Guys, this time I will use Python and Numpy. If you're familiar with Python and Numpy, please watch this video. If not, just try to understand some concept. I'll use Python as a Numpy one here, and I'll create the training data like this one. X will is Numpy array. We start from 0 1 sorry 1 0 0, that is x0, right? And x, the next one 0 1, right here, and 1 1 0, and the last training data is all of them are 1. Okay, this is x, and this is a target. The target one is can be like 0 0 0 1, right? Yeah. Okay, so we have the weight also. So the weight should be you can start like you can use np random also, so it can be just weight is connecting. Okay, to start working with the blue is np dot. In this case, we'll use this one, function random of numpy. Okay, so for random numpy, okay, it would be like I will to test for this random first. Yeah, so it must be random again, and we have provided size, that is should be like 1 row and 4 columns. Let's try. Okay, let's check the blue here. It is like this. Okay, but sorry, actually it should have only 3, because you have 3 inputs, so the blue is 3 right here. So in this case, if you have the blue, I'd like to show you how can numpy work. So I'd like to test for x0 is 1 0 1, right? Sorry, 1 0 0. So I'd like to times x0 by the blue. Can you see? Now you can find the summation of these values, right? It can be this one is numpy sum of x0, the first line, times this the blue. Okay. If you use the x2, please guess the result. It will sum these values and these values, right? So it should be like around 0.44 something. So let's try to check the result. x2. Yes. So this one can be the values that you can get from the blue dot x, or the blue summation of the blue times x. Okay, so I'd like to start training, like for I in range 10,000 iterations, 10,000 epochs, but for each epoch means one round of all iterations, all data. So in this case, one epoch contains 4 iterations because we have 4 examples. So in range 4. Okay. So guys, in this case, we will find the output from x, right? So we will use xj, right? This one is the output, right? And we have to find delta w, right? For the delta w, you have to use like this. Delta w will be an array of 1 row and 3 column like this, and I'll add delta w j. Sorry, a moment. We have to use this one to be 1 row and 3 columns. It should be like this, and you have to access the w0j to be the attributes that you want. Okay, so for each delta, you have to find this term. You have to find the target, that is target j minus output here. Oh, sorry, output cannot be this one. You have to pass it through the SIgmoid function. So the actual output should be 1 divided by 1 plus x e power minus o. So it will be target minus o times the learning rate. In this case, I set the eta to be 0.1. So it will be eta times target minus output times output times 1 minus output and times x. Actually, you can think that this one is xj. And this is the delta w, but you can use this value to add to w also. So w can be w plus this delta. Okay. Maybe it's still incorrect because we need to check for the dimension of x and w. It can be combined together. So let's try. Okay, so for the dimension of x, j, and w now is fine. It's correct. So you can use w to be like this. W is w plus the delta. Delta is learning rate times target minus output times 1 minus output times xj. So you can sum it to w. Okay, so once you finish all iterations, just check the w. Yes, is the one that you can use. So you can try to check w for for all examples. So I can start from 4j in range 4. I'd like to try all example and check the output. For the first one, we have to use this value. Output is np.sum xj times w. This is O, and you have to find the sigmoid of O. Yes, and print the result. So it should be like should be close to 0, should be close to 0, close to 0, close to 0, and the last one should be close to 1, right? Let's see the result. This one is close to 0, right? Close to 0 and close to 1. So this is the result. And if you add like 100,000 epochs, so the one that you get will be like this. So we can wait for later here. Can you see this is close to 0, close to 0, close to 0, and close to 1. This is a graph, or sorry, this is the result that we want. So guys, I hope that you can see that we can train sigmoid function here. Or if you're familiar with Numpy, please study this video clip in carefully. But if you're not familiar with Numpy or Python, you can just watch this video clip, and if you want, you can try to understand it. But you have to stick on the Google spreadsheet that we just trained. Okay, so this one is the end of the SIgmoid unit. So now you can train the SIgmoid unit using very simple training rules. See you in the next video clip.